I'm Dr. Leonard Kazan from Camden County College, and today we will measure resolution of a CCD camera, charge coupled device camera. Here you have one. As you see inside of that camera, the objective is taken away. You can see a CCD sensor, a charge coupled device sensor, that consists of several thousands of microphoto detectors. They're called pixels. They have several hundred pixels horizontally, several hundreds of pixels vertically, so we have a two-dimensional array of these CCD microphoto detectors. We will measure resolution of such a camera. By the way, this particular camera is a 0.3 inch camera. That means the diagonal of this sensor is 0.3 inch. So we can measure the horizontal and the vertical dimensions of the sensor in millimeters. To find the resolution of this camera, we have to use the so-called resolution targets. And for instance, one of them is printed in your textbook. This has 75 line pairs per inch. The width of this target is 1 inch, and it has 75 black and white lines. You also can use this resolution target. This one has 1 line per millimeter, but even better to use so-called US Air Force 1951 resolution target, because it has many patterns of specific shape. First of all, it has lines oriented vertically and oriented horizontally, so it can be used to measure in one pass both horizontal and vertical resolution, because they are different, and you can see which pattern will be resolved, so it will give you the critical resolution. Together with 1951 US Air Force resolution target, you can use this target. This is called NBS, National Bureau of Standards 1963 resolution target. You also see it contains vertical and horizontal bars, and numbers near these bars tell you how many bars per millimeter you have. So you definitely know the pattern of your resolution target. To do this lab, you need a CCD camera, either this one or even a computer video camera, any camera, and a target. For instance, either one of these I showed you or one used from your textbook. And you can do the following thing. You will focus your camera on a target like this, and then increase the distance between the camera and the target. Please look at this board. You will see exactly this pattern, and this camera will give you the image it shows on a monitor. You will increase the distance between your target and the camera if you use the resolution target until these lines become barely resolvable. And then comparing the image of this target on the monitor with the complete image size, you can easily find the number of pixels in your resolution camera, because when these lines stop to be resolvable, that means that you exactly have 1 line per pixel. So 1 black line on a pixel, 1 white line on a pixel, 1 black line on a pixel, 1 white line on a pixel. And that will allow to find the horizontal number of pixels in your camera. If you orient this, if you turn this 90 degrees, similarly you can find a number of vertical pixels in your camera. And knowing the size of your sensor, you can easily find how many lines per millimeter or per inch, if you measure in inches, you can resolve. So this is the objective of our lab. Let's summarize your actions about this experiment. You have your target with the known resolution n small. For instance, in the case, if you use your textbook, it's 75 line pairs per inch. Then you connect this camera to video monitor and focus on the target to get the lines oriented vertically in the image clearly distinguishable. Then, keeping the camera in focus, you move your camera and the target farther from each other in such a way that the lines stop to be distinguishable. And the camera now has a one line per pixel imaged on the CCD array. This is the resolution limit of the camera sensor. Then you measure the width of the image of the target, lowercase l, and you measure in the same units the horizontal width of the whole image window. It's capital L. Please look at the figure. They clearly are shown in the figure. So lowercase l is the image of the target on the monitor, and capital L is the width of the full image received by your camera. Then, as you can see from the next slide, you can compute the number of horizontal pixels of the camera as your resolution, small n, times the ratio of the image size L, capital, over the target image size L, lowercase. And you can compare it with the number of the specification if available. If you know the horizontal size D of the array, you also can calculate the resolution of the camera R, as you see from the formula. It's the number of lines per inch of the target divided by the doubled width of a camera. Doubled width of the CCD sensor. Double width because one white line takes 1 pixel and one black line takes 1 pixel. That is why you have to divide small by 2. And then you reorient your target 90 degrees, so the lines are oriented horizontally now, and repeat the experiment to determine the number of vertical pixels on the camera. With these data, you fill the table 1 for the horizontal resolution. Again, here D sub H is the horizontal size of your CCD sensor, if available. And then for the vertical resolution, after you turned your target 90 degrees, you fill the table 2. If you use the US Air Force target, because it has both vertically and horizontally oriented lines, you can fill both tables without rotation of the target. So that is your experiment.